We are capable of shaping wood into tables and chairs. We can fire clay into teacups and teapots, but we cannot manufacture a single automobile. Not one airplane, not one tank, not even a tractor. These were not the words of a modern politician engaging in theatrical humility. They were not spoken to lower expectations or deflect blame before an election. They were a blunt, humiliating confession, delivered in the early 1950s by Mao Zedong himself, the founding architect of the People's Republic of China. When Mao said this, he was not exaggerating. He was diagnosing the terminal condition of a nation that had just survived, but barely. China at mid-century was not simply poor, it was industrially hollow. For nearly 50 years, the country had been torn apart by uninterrupted catastrophe. First came the fragmentation of the warlord era, when regional strongmen carved the nation into personal fiefdoms. Then came the Sino-Japanese War, a campaign of annihilation that destroyed what little industrial capacity China possessed. That conflict bled seamlessly into the global inferno of World War II, followed immediately by the brutal, fratricidal violence of the Chinese Civil War. There was no recovery period, no rebuilding phase, only exhaustion layered on top of ruin. By the time the Communist Party took power, China's industrial base was not merely damaged, it was functionally non-existent. To say that industrial output was close to zero was not rhetorical flourish. It was a daily, terrifying reality. China could not cast an engine block. It could not forge high-strength steel. It could not build the machines required to build other machines. And to the leaders of the new republic, this weakness was not an economic inconvenience. It was an existential threat. A nation that cannot manufacture its own tools is a nation that must depend on others for survival. And dependence, in a world ruled by tanks, aircraft, and factories, was simply another word for future subjugation. This was the fear that haunted China's leadership, and it would become the fuel for a transformation that would span 7 decades, a silent war fought not with armies, but with factories, supply chains, and industrial knowledge. Faced with this reality, the Chinese leadership reached a conclusion that would define the nation's future. Political ideology meant nothing without industrial muscle. In 1955, driven by fear as much as ambition, the state broke ground on a massive industrial project in the ancient city of Luoyang, in Henan province. This was not a random location. Luoyang sat at the crossroads of history, once a capital of Chinese civilization, now chosen to become the cradle of its industrial rebirth. The project was China's first domestically produced tractor factory. At the time, this decision carried immense symbolic weight. A tractor was not a luxury good, it was not glamorous, but it represented something far more important: the ability to mechanize agriculture, to free human labor, and to feed a nation without relying on foreign machines. 3 years later, in 1958, the factory doors opened. Rolling out onto the assembly floor was the Dongfang Hong. The East is red. The name was not subtle. It was a declaration of intent. The East would rise. It would rise on steel forged by Chinese hands, powered by Chinese engines, driven by Chinese farmers. This single machine was meant to signal that China had taken its first step out of industrial darkness, but the tractor was only half the story. Right next to this flagship factory, the state commissioned another facility, one that, at the time, seemed far less important. A supporting plant, a background project. It was a bearing factory. Ball bearings are not impressive to look at. They do not dominate parades or feature in propaganda posters. They are small, silent components, hidden inside machines, doing their work unseen. Yet bearings are the joints of modern civilization. Every engine, every turbine, every train axle, every piece of rotating machinery depends on them. Without bearings, motion itself becomes impossible. The decision to build a bearing factory alongside the tractor plant was not accidental. It reflected a deeper realization. Industrial power does not begin with finished products. It begins with mastery over the smallest, most fundamental components. These two factories became the crown jewels of China's first 5-year plan, part of the legendary 156 projects modeled heavily on the Soviet Union's rapid industrialization strategy. Mao believed that only one system in history had proven capable of dragging a backward, agrarian empire into modernity fast enough to survive: the Soviet model. This was not merely an economic program, it was a survival strategy. The Chinese state was planting the seeds of a long war, a generational struggle to ensure that China would never again be held hostage by nations that could build machines while it could not. Few at the time could have imagined how far this obsession would go. Fewer still could have predicted that this unassuming bearing factory would remain relevant more than 70 years later, at the very center of a global industrial confrontation. Fast forward 7 decades, the transformation is so extreme that it borders on the unbelievable. The nation that once could not build a single tractor now stands as the world's second largest economy. And a near-peer competitor to the United States, China is often called the world's factory. But the phrase barely captures the scale of what has occurred. China produces more steel than the rest of the world combined, more cement, more ships, more industrial goods of every category that matters. It has constructed the largest high-speed rail network ever built by a single country. It operates the most active patent system on Earth, from the smartphone in your pocket to the structural steel in your office building. Global supply chains now run through Chinese factories. To many observers, this looks like total victory, an industrial leviathan wrapped in armor made of scale, speed, and cost efficiency. But armor can hide weakness. Beneath this outward dominance lie structural fractures, narrow, fragile points where the entire system depends on foreign technology. Experts refer to these vulnerabilities as industrial choke points. A choke point is not a broad weakness, it is a specific, highly specialized component or process without which an entire industry collapses. Miss it, and nothing moves. China knows where these choke points are, Washington knows too, and quietly celebrates them. In strategic circles, these vulnerabilities are seen as invisible nooses, mechanisms that the United States and its allies can tighten in moments of crisis, cutting off China's access to technologies it cannot yet replace. This raises a dangerous question. After 70 years of relentless industrialization and trillions of dollars in investment, why does China still struggle to master certain critical components? Why can a nation that builds the world's fastest trains still depend on foreign suppliers for the parts inside them? And perhaps most unsettling of all, can these weaknesses actually be exploited? Or is the attempt to weaponize them accelerating China's drive to eliminate them entirely? To answer that, we have to look under the hood of China's economic engine, not at the parts that gleam, but at the components, so small, so technical, that their failure would bring the entire machine to a halt. Before we do that, the channel makes its brief introduction, not as a detour, but as a statement of intent. This is a story about wars not fought with soldiers, but with supply chains, about empires built not on conquest, but on the quiet mastery of industry itself. In May of last year, China's president, Xi Jinping, returned to Luoyang. The visit was not ceremonial. It was deliberate. He toured the Luoyang Bearing Group, the modern descendant of that modest factory built in the 1950s. Standing amid the hum of precision machinery, Xi delivered a message that sounded part history lesson, part warning. We have come a long way, he told the engineers. We went from importing matchsticks to becoming the world's largest manufacturer. Then came the real point. But we must persist. We must master the core technologies ourselves. She did not choose a semiconductor lab for this speech. He did not stand before a rocket engine or a nuclear reactor. He chose a bearing factory because Xi Jinping understands something that many in the West overlook. Industrial power is cumulative. It is built from the bottom up. To understand why this matters to Xi, we have to understand the world that shaped him. Xi Jinping is a political product of two eras. His father, Shi Zhongshan, was a revolutionary comrade of Mao and one of the early architects of the Chinese state. In the 1950s, he was sent to the Soviet Union to study how modern industrial society was managed. The young Shi grew up in the shadow of the Soviet model, a worldview that equated heavy industry, state planning, and technological self-reliance with national survival. He witnessed the peak of Sino-Soviet cooperation, when Russian engineers helped design Chinese factories and entire industrial cities, from farmland. But he also witnessed the collapse, when the Soviet Union disintegrated in 1991. She was rising through the ranks of the Communist Party, unlike many Western observers who frame the collapse as a victory for democracy. She studied it as a strategic failure. His conclusion was stark. The Soviet Union did not fall simply because it liberalized politically, it fell because it became technologically stagnant and economically brittle. It relied too heavily on oil exports. It neglected civilian manufacturing. It could build missiles, but it could not build competitive consumer goods or advanced microelectronics. In Xi's mind, this was a death sentence. When Xi took power in 2013, his initial approach was cautious. China would grow quietly, it would integrate into global markets, it would avoid direct confrontation with the American-led order. That illusion shattered in 2016, the election of Donald Trump and the launch of the U.S.-China trade war revealed a hard truth. The United States would not passively watch China rise. Tariffs followed, blacklists followed, technology bans followed. To Xi, this was the moment the mask slipped. China was not engaged in competition, it was engaged in struggle, and so the strategy changed. The goal was no longer just wealth, it was strategic invulnerability, a condition in which no foreign power could cripple China by cutting off critical technologies. From that moment on, industrial choke points stopped being technical footnotes, they became matters of national security. In 2018, something extraordinary happened. China's state-run newspaper, Science and Technology Daily, published a series of articles that amounted to a public self-indictment. For a political system built on projecting strength, this was almost unheard of. The articles identified 35 distinct technologies in which China remained dangerously behind the world's industrial leaders. This was not foreign intelligence, it was not Western speculation, it was China, speaking to itself. The list included the obvious vulnerabilities that analysts in Washington had long focused on, and semiconductors, high-end chip design, and precision manufacturing tools, but it also revealed weaknesses that few outside specialist circles fully appreciated. Heavy-duty gas turbines used in power plant and aircraft, high-pressure hydraulic components essential for construction and mining equipment, tactile sensors that allow robots to feel their environment, and, buried among them, a component so mundane that most people never think about it at all, high-end ball bearings, too. Policymakers in Beijing, this list was not an embarrassment, it was a roadmap. Analysts in the United States quickly took notice. Former CIA linguist and analyst Ben Murphy was among those who translated and studied these articles. What Washington realized, almost with disbelief, was that China had published its own industrial fear map. This document revealed not just what China lacked, but what it feared losing access to in a crisis. It showed exactly where pressure could be applied, and where China would concentrate its efforts to escape dependence. Of all the choke points on that list, bearings deserve special attention, not because they are the most glamorous, but because they reveal how modern industrial power actually works. To understand why, we need to zoom in, far closer than most people ever do, on a piece of steel smaller than a marble. At first glance, a ball bearing looks trivial. It is just a small sphere of steel designed to reduce friction, something you might find in a skateboard, a washing machine, or a desk fan. Hardly the kind of object you would expect to sit at the center of a geopolitical confrontation. That assumption is a mistake. In the world of high-precision engineering, a bearing is a technological marvel. We are not talking about steel balls you can see with the naked eye. We are talking about spheres that must be perfectly round to within a millionth of a meter at extreme rotational speeds. Even microscopic imperfections become lethal. Consider a high-speed train traveling at 350 kilometers per hour. If a single bearing inside its axle contains a flaw smaller than a grain of dust, friction increases. That friction generates heat. The heat causes deformation. The deformation accelerates wear. At those speeds, failure does not mean inconvenience. It means catastrophe. The metallurgy required to prevent this is astonishingly complex. Bearing steel must be almost perfectly pure. Oxygen, sulfur, titanium, and microscopic oxides must be removed almost entirely. If even one impurity remains, it becomes a fatigue point, a place where cracks will eventually form under stress. For decades, Chinese steel mills could not achieve this level of purity. They could produce massive volumes of structural steel for bridges and buildings, but precision steel for bearings, jet engines, and turbines remained out of reach. The global market for these high-end bearings became a closed club. 6 companies dominated: Sweden's SKF, Germany's Schaeffler, and Japanese giants like NSK and NTN. These firms are not just manufacturers, they are custodians of trade secrets accumulated over more than a century, recipes, processes, and techniques passed down across generations of engineers. China manufactures billions of low-cost bearings every year, but when it comes to the bearings required for jet engines, CT scanners, precision robotics, and high-speed rail, China still imports the vast majority of them. This is a choke point. If the West were to ban the export of high-grade bearing steel tomorrow, the impact would be immediate. The pride of China's infrastructure, its high-speed rail network, could grind to a halt. And Beijing understands this vulnerability better than anyone. The question is not whether China accepts this risk, it is how far the state is willing to go to eliminate it. China does not respond to vulnerability with resignation. When Beijing identifies a choke point, it does not ask whether the problem is solvable. It asks how long it will take and how many resources it must throw at it. On the outskirts of Wuxi, at a company called Deep Vision Technology, a quiet revolution is underway. Rather than trying to replicate a century of German or Japanese craftsmanship, engineers have taken a different approach. They are attacking the bearing problem with better eyes, not better hands. Deep Vision has developed an AI-driven computer vision system capable of detecting surface defects as small as 2 micrometers, far smaller than what traditional inspection systems can reliably catch, where human inspectors and conventional automation miss flaws. Machine learning models trained on millions of samples do not. Traditionally, bearing inspection was slow, expensive, and prone to inconsistency. It depended on experienced technicians whose judgment took decades to develop. China does not have decades to wait. By integrating artificial intelligence directly into quality control, Chinese manufacturers are attempting something radical: to compress a century of accumulated industrial knowledge into algorithms. This is the Chinese playbook when you cannot beat your competitors. At traditional manufacturing culture, you change the rules of the game. You layer digital systems on top of physical production and let scale do the rest. By analyzing microstructural patterns and correlating them with failure rates, these AI systems are rapidly improving manufacturing yield and consistency. Each production run becomes training data. Each defect makes the system smarter. Executives at major Japanese bearing firms have quietly admitted, including in interviews with the Financial Times, that while China still lags in design sophistication, its manufacturing consistency is improving at an alarming pace. This pattern is not unique to bearings. It is repeating across multiple choke points, again and again, to see how dangerous this approach can be. We only need to look at where China has already succeeded. The Bering story is not an exception, it is a template. Once China identifies a choke point, the response follows a familiar pattern. First, the state acknowledges the vulnerability internally. Then it floods the sector with capital, talent, and policy support. Finally, it scales production so aggressively that foreign competitors are forced into retreat. Take lithium battery separators. A battery separator is a thin membrane placed between the anode and cathode. If it fails, the battery short circuits. In electric vehicles, failure means fire. A decade ago, China imported nearly all high-end battery separators. This was a critical weakness for a country betting its future on electric mobility. Beijing moved decisively. Research was subsidized. Domestic demand was guaranteed. Companies were allowed to lose money for years in pursuit of scale and mastery. Today, firms like CATL and BYD dominate the global market. They did not simply copy Western designs. They improved them, increasing safety, improving yields, and driving prices down so far that many foreign competitors could not survive. The same pattern appears in LiDAR, the laser eyes of self-driving vehicles. Early LiDAR systems were bulky, spinning cylinders that cost upwards of $75,000 per unit. China identified LiDAR as a future strategic technology and poured billions into startups and research institutes. A massive domestic EV market provided something Western firms lacked: real-world data at scale. Today, Chinese companies lead in cost-effective solid-state LiDAR, transforming what was once a choke point into a competitive advantage. But not every battle ends in victory. Carbon fiber remains a stubborn frontier. This material is lighter than aluminum and stronger than steel, making it essential for aerospace, centrifuges, and advanced missile systems. The manufacturing process is a chemical dark art involving precise heat treatment of polyacrylonitrile fibers. Despite for decades of effort, China still struggles to mass-produce aviation-grade carbon fiber that meets global safety standards. A handful of Japanese firms continue to dominate the high-end. This failure matters. It keeps Chinese aircraft like the C919 dependent on foreign suppliers. Reminder that not all choke points yield easily, and yet, looming over all of them is one vulnerability that dwarfs the rest, the mother of all choke points: semiconductors. Semiconductors are the oil of the 21st century. Almost every modern system of power depends on them, from smartphones and data centers to fighter jets, radar arrays, and hypersonic missiles. Advanced chips sit at the core. For years, China understood this dependency, but chose convenience over confrontation. It was cheaper and faster to buy chips from Intel, Qualcomm, and Nvidia than to build an entire domestic ecosystem from scratch. That calculation ended when the United States decided to weaponize the supply chain through a web of export controls and the Foreign Direct Product Rule. Washington effectively banned China from accessing the most advanced chip-making tools on Earth. At the center of this blockade sits a single company, ASML. The Dutch firm produces extreme ultraviolet lithography machines, EUV tools so complex that they are often described as the most advanced machines humans have ever built. They are capable of etching circuits just a few nanometers wide. Without EUV, you cannot manufacture the chips that power the latest iPhones, AI servers, or advanced weapons systems. The United States understood this leverage and used it. Huawei was placed on the entity list, cut off from Google's Android ecosystem, cut off from Taiwan's TSMC. Most analysts predicted collapse. They were wrong. Instead of dying, Huawei transformed itself. The company became the coordinator of a national resistance effort. It began quietly investing in dozens of obscure Chinese firms, companies that produce optics, specialty chemicals, lasers, and chip-making subsystems that most people have never heard of. Earlier this year, Huawei founder Ren Zhengfei, an 80-year-old former army engineer, pledged that a coalition of more than 2,000 Chinese companies would achieve 70% self-sufficiency across the semiconductor supply chain by 2028. This was not corporate ambition. It was wartime mobilization. The shock came when Huawei released the Mate 60 Pro smartphone, powered by a 7-nanometer chip manufactured domestically by SMIC. While still behind the cutting edge, the message was unmistakable. Sanctions had not stopped China. They had merely slowed it down, and in doing so, they forced China to build a parallel supply chain, one increasingly immune to American law. There is an uncomfortable irony at the heart of America's containment strategy. For years, U.S. policymakers assumed that denying China access to advanced technology would freeze its progress. That pressure would expose weaknesses, trigger internal frustration, and eventually force political concessions. Instead, the opposite may be happening. By weaponizing technology access, the United States removed China's easiest option, buying. Before the trade war, Chinese tech firms had little incentive to build their own chips. Purchasing processors from Intel, Qualcomm, or Nvidia was cheaper, safer, and faster. Sanctions changed the math. Buy versus build stopped being a business decision. It became a matter of national survival. This realization has created strange bedfellows. During recent campaign rhetoric, Donald Trump hinted at allowing Nvidia to resume selling certain AI chips to China, not out of goodwill, but out of fear. Nvidia's argument was blunt: if American firms cannot sell advanced AI hardware to Chinese companies, then Huawei will fill the vacuum. Chinese firms will be forced to adopt Huawei's Ascend chips instead of Nvidia's H100s. That shift would give Huawei something far more valuable than short-term revenue. It would give it data. It would give it software ecosystems. It would give it developer lock-in. In other words, containment risks creating the very competitor it seeks to prevent, one that could eventually challenge American dominance globally. The admission is subtle, but profound. The window to strangle Chinese technological growth may already be closing, and the numbers suggest why. In 2024 alone, China spent nearly $500 billion on research and development. That investment is not flowing into flashy tech giants. It is being funneled into what Beijing calls little giants, small, specialized firms designed to solve very specific industrial problems. These companies focus on one thing: a particular hydraulic valve, a specialized laser, a niche. Chemical photolysis. Profit is secondary. Sovereignty is the goal. What we are witnessing is not just a rivalry between China and the United States. It is the collapse of an entire economic era. For decades, globalization was built on a simple assumption: efficiency mattered more than geography. Nations specialized. Supply chains stretched across continents. If one country could make a component cheaper, everyone benefited. That era is over. In its place, a new doctrine is emerging: industrial mercantilism. In this world, nations fight to control every link in the supply chain, not because it is efficient, but because it is survivable. China understands this instinctively. It is racing to close its remaining vulnerabilities before a future crisis, perhaps over Taiwan, turns them into fatal liabilities. Every choke point eliminated is one less lever a foreign power can pull. The United States is making a different bet. It is betting that technological complexity is now so high that no single nation can master it alone. That alliance networks, Japan, the Netherlands, South Korea, can hold the line long enough to preserve American leadership. China is betting on something else entirely: scale, engineering talent, time, and an unyielding belief that survival justifies any cost. It is betting that a civilization capable of building the Great Wall can eventually build a lithography machine. And that bet forces an uncomfortable question on the rest of the world. Most nations consume advanced machines. Very few can make them. In a world where industry equals sovereignty, what happens to countries that outsource their ability to build? 70 years ago, China learned a brutal lesson. A nation that cannot manufacture its own tools will eventually be ruled by those who can. That lesson was forged not in boardrooms or universities, but on factory floors, in places like the bearing plant in Luoyang, a facility built in desperation, overlooked for decades, now standing at the center of a global industrial struggle. The story of that factory is not nostalgia, it is a warning. Industrial power is not granted, it is not inherited, it is seized, slowly, painfully, and deliberately, today. The furnaces of Chinese industry are burning hotter than ever, not because China seeks domination, for its own sake, but because history taught at what vulnerability costs. The question is not whether China will try to eliminate its remaining choke points. It already is. The question is whether the rest of the world understands what this means. In an era where supply chains are weapons and factories are fortresses, neutrality is an illusion. We can choose to remain customers, or we can choose to remain capable. As the world's factory retools itself for a new century of competition, one truth remains unchanged. Those who cannot build, obey. If you found this deep dive valuable, consider subscribing and sharing it. Long-form analysis survives only when audiences demand more than headlines, and in the comments, ask yourself, and everyone else, will China close the final choke points, or will containment succeed? I'll see you in the next one.